In the first question here, we need to multiply everything by 4 to get rid of the fraction in the first term. So if we do that, term by term, for the first one, multiplying by 4 leaves us with the numerator 2t minus 3. Multiply the next term by 4 and we get minus 8 into t minus 3. Then on the right hand side, again multiplying everything by 4, 4 times 5 is 20. And then 4 times minus 3 gives us minus 12 into 2 plus t. Next we can remove the brackets and then gather the t terms on the left, everything else on the right. So first of all, expanding the brackets, we've got minus 8t, minus 8 times minus 3 is plus 24, and then minus 12 times 2 is minus 24, and then minus 12t. Got all the t terms on the left. So we've got 2t minus 8t, and then plus 12t, but minus 12t, you can either think of that moving across the equal sign to change from minus 12t to plus 12t, or just add 12t onto both sides. So on the right, 12t cancels with minus 12t, but we must also add 12t on the left hand side. And similarly, the other terms without a t have got to move in the other direction, or think of adding them onto both sides of the equation. So minus 3 crosses the equal sign to become plus 3, 24 crosses the equal sign to become minus 24, and then the other two terms stay where they are. So on the left then, we've got a total of 2 minus 8 is minus 6, plus 12 is 6t. And on the right, we've got 3 minus 24 is minus 21, plus 20 is minus 1, minus 24 is minus 25. And therefore, dividing both sides by 6, or using the idea of cross multiplication, where the 6 can move diagonally across the equal sign to go underneath it, minus 25, we end up with t equal to minus 25 over 6. And question 2, part A, we have to use the chain rule. So we can either just think of the bracket as a single variable, and therefore say that d by dx, the derivative, is equal to 4 times the bracket, bringing the power down to the front, to the power reduced by 1 times the derivative of the inner function. Well, the derivative of 2x cubed minus 1 is just going to be 2 times 3 is 6 times x to the power 2. Contents of the bracket don't change. And we can rearrange that to be 24x squared into 2x cubed minus 1 all cubed. More formally, you might rewrite the original expression as v to the power of 4, and then say that df by dv, or df by dx, is equal to df by dv times dv by dx. So we're saying f is equal to v to the power of 4. df by dv would be 4v cubed, and dv by dx is going to be again 6x squared. So if we replace v with the content of the bracket there, we can see we're just going to get the same result. Part B, we need to use the product rule because we've got, well, in part A we're using the chain rule because we had a function, a power of a function of x, or a function of a function. Part B, we've got a function times another function, so we need to use the product rule. It says if we've got f times g and we want the derivative of that, which we can either show with a dash or d by dx. The derivative is given by f dash g plus g dash f. So in this case, if we call f x cubed and g natural log of x, well, f dash is going to be 3x squared. G is just the second function, so natural log of x. G dash, the derivative of natural log of x is 1 over x times the first function, x cubed. Now, x cubed times 1 over x is the same as x cubed divided by x, which is x squared. So this comes to 3x squared natural log of x plus x squared. So you could take x squared out as a common factor, and to decide what goes in the other factor bracket, divide the original terms by the common factor. So in the first term, x squared cancels with x squared, leaving 3 natural log of x, and in the other term, x squared divided by x squared, just a plus 1. Part C, we need to use the quotient rule that says if we've got a function f divided by a function g, then the derivative is given by f dash g minus g dash f all over g squared. So in this case, f dash, derivative of x plus 2, is just going to be 1. So times g is 3x minus 1. Minus g dashed, derivative of 3x minus 1 is just 3. Times f, the top function, x plus 2. That's all over g squared. So simplifying the numerator, we can see 3x will cancel with minus 3x. So we just have a constant terms, minus 1 minus 3 times 2 gives us minus 7 for the numerator. And for question 3, we just want to integrate 1 plus e to the minus x. With respect to x between 0 and 2. So we need to know the integral of 1 is, well, it's the same as, well, 1 is the same as x to the power of 0. So if we can use our power law, we know we increase the power from 0 to 1, divide by the new power, so we know the integral of 1 is x. The integral of e to the power kx is 1 over k e to the power kx. In our case, k is minus 1 because we've got the power of minus x. Therefore, minus e to the minus x, since 1 over minus 1 is the same as just minus 1. Square brackets, after we've done the integration, move the limits to the right hand side. Then apply the limits. So what we get when we replace x with 2 is 2 minus e to the minus 2. Then subtract what we get when we replace x with the lower limit, 0. So that's 0 minus e to the power 0 is just 1, and e to the power 0 is 1. So then this becomes 2 minus minus 1 is 3. Minus e to the minus 2 we could rewrite as minus 1 over e squared, since the negative power can be rewritten as 1 over the positive power.